This is an illustration showing how cross reactions happen. So what you're seeing here are red blood cells with the B surface antigen on them. So these are going to be, this is going to be for type B blood. So if this sample of blood was given, if this is the donor's blood, in other words, so the donor has type B, and this blood is transfused into someone who's type A, the person who's type A is going to have B or anti-B antibodies in their plasma. So once the donor blood mixes with the recipient's anti-B antibodies, once it mixes, those antibodies are going to, you see how they have a little shape on the end that kind of allows them to attach to the antigens? So the antibodies are going to attach to the antigens, and it causes the red blood cells to clump. You can see from the illustration how that would work. And once they clump, they can also lyse, which can be extremely dangerous. So this is how a cross reaction occurs. This is a picture of the results of a blood typing test so that you can see how that works. Basically what you do is you put a drop of someone's blood into, you just take 3 drops of their blood. And in one of the drops you add an anti-A serum that contains anti-A antibodies. If you mix that with their blood and you get clumping, then that means they have the A antigen on the surface of their red blood cell. If you don't get clumping, in this case there's no clumping in the anti-B serum, then that means they don't have the B antigen on the surface of their red blood cell. You do get clumping in the anti-RH serum. That means that they have the RH antigen on the surface of their red blood cell. So this is going to represent blood type A positive. Everywhere you have clumping, you have that antigen on the surface. So there's no clumping in the A, but there's clumping in B and RH, so you are B positive. When you have clumping in all 3, then you are AB positive. In the bottom row, there's no clumping in any of the serum reactions. So this person doesn't have A, B, or RH antigens on the surface of their red blood cell, so they are O negative. So that's how blood type tests are done. We do have some terminology that we use sometimes with blood typing. Universal donors, the blood type that can donate to any other blood type, is type O blood, and especially type O negative, because O positive would still have the RH antigen on the surface of their red blood cells, but O negative they wouldn't introduce any surface antigens to the recipient. And then the universal recipients have type AB blood. They can receive from anyone. The checkpoint question says, which blood types can be safely transfused into a person with type AB blood? Let's make this a little bit more complicated than that. Let's say type AB negative. Okay, so this person is type AB negative. What that means is their red blood cells have the A and B surface antigens, but they don't have the RH. So any of the negative blood types can be transfused into this person's blood. You could be type A negative, type B negative, type AB negative, or type O negative, and safely donate to this person. But if you have a positive blood type, then it wouldn't be safe. All right, we're going to move on to the white blood cells. The name for white blood cells in general is leukocytes. White blood cells are larger than red blood cells. Their purpose, their function is to defend the body against pathogens. to remove toxins, waste, and abnormal or damaged cells, kind of like the garbage collectors. And the white blood cells do have a nucleus and other organelles, unlike red blood cells. Okay, there are two types of white blood cells. There are three of them that are called granulocytes because they have granules in their cytoplasm that you can see under the microscope. They are neutrophils, eosinophils, basophils. Then the agranulocytes, which don't have many of these granules, are the lymphocytes and the monocytes. The neutrophils, eosinophils, basophils, and monocytes, those four are part of the body's non-specific defense. They respond to any threat without having to identify specific pathogens. So they're part of our non-specific immune system. Lymphocytes are responsible for our specific defense or adaptive immunity. This is when we develop immunity to like a certain virus or a certain bacterium. Once we've been sick from one type of pathogen before and we have developed an immunity to it, it's the lymphocytes that are responsible for that. So they respond to specific pathogens. There's like a lymphocyte for each specific pathogen that could infect your body. All right, let's start with the neutrophils. The neutrophils by far are the most abundant of the white blood cells in our circulation, over half of them. They're usually the first responders when you get injured, so the first white blood cell to arrive at the site of injury. They are phagocytes. That means that they attack and engulf bacteria and digest it or destroy it, break it down. Eosinophils, under the microscope, they have granules that stain red, and you will see higher numbers of eosinophils when you have parasites or allergic reactions. Basophils have granules that stain deep purple or blue. You can see that here. They migrate to injury sites and they release two chemicals, heparin and histamine. Heparin is a blood thinner. Actually, some people take it as a medication. And histamine is a chemical that increases the inflammatory response. So histamine dilates your blood vessels and enhances inflammation. Monocytes are the largest of the white blood cells. They're going to be really large. They're about twice the size of a typical red blood cell. They're larger than any of the other white blood cells. And they contain like a kidney-shaped nucleus, kidney bean-shaped nucleus. They also differentiate or specialize. They become macrophages when they leave the circulation and enter your tissues. They become macrophages, which are big eaters, big phagocytes. They're very aggressive phagocytes that can engulf lots of bacteria at one time, or lots of damaged cells, whatever. They can engulf a lot of material at once. Then we have the last white blood cell, which is the lymphocyte, and the size of the lymphocyte is just a little bit larger than a red blood cell. So they're the smallest of the white blood cells, and the nucleus is almost as big as the lymphocyte. You end up seeing a large nucleus under the microscope and just this thin rim of cytoplasm outside the nucleus. Some lymphocytes attack foreign cells and other lymphocytes produce antibodies, but they definitely respond to specific pathogens. The pathogen has to be, say, the COVID virus or E. coli bacteria. Each lymphocyte responds to a specific thing, specific threat. So let's look at some of the medical terms. If you ever hear leukopenia, that means that the numbers of white blood cells are too low. If you hear leukocytosis, that means that the number of white blood cells is too high. If you have a large number of neutrophils, that indicates you have an infection of some kind, a larger number than normal. And leukemia is cancer of blood-forming tissues. It's blood cancer. So we can detect it because there's a lot more leukocytes than normal, excessive numbers of leukocytes, which we call leukocytosis, or the white blood cells that are present are abnormal or they're immature. There's something wrong with them. All right, checkpoint questions. Question 13, which type of white blood cell would you find in the greatest numbers in an infected cut? And that would be the neutrophils, the first responders. And 14, which type of cell would you find in elevated numbers in a person producing large amounts of circulating antibodies to combat a virus? So the white blood cells that produce antibodies are called B lymphocytes. Well, they're actually called plasma cells, but they originate as B lymphocytes. The other lymphocytes are called T lymphocytes. So the answer is lymphocytes for 14. Okay, platelets. A lot of the medical terms that involve platelets or blood clotting or blood clots use the word part thrombo. I actually just learned this today, and this is news to me. I've always called platelets thrombocytes. But technically, if you look back at this information, thrombocytes are platelets that, when you find them in vertebrates that are not mammals, but in humans, we just call them platelets. And they're cell fragments of, like basically cell fragments that are shed from megakaryocytes, which you find in the red bone marrow. They're stem cells that are in the red bone marrow, and that fragments of them. So we're just going to call them platelets, since we are humans and not non-mammalian vertebrates. Platelets are involved in blood clotting because of the amount of material in the cardiovascular system. I'm not going to have you learn all the different steps and the details about blood clotting, but just know that platelets are involved in it. A low platelet count is called thrombocytopenia, and a high platelet count is thrombocytosis. I hope you've noticed that cytosis is indicating high, so erythrocytosis, leukocytosis, thrombocytosis is high counts of those types of cells. So once you are actually bleeding, when you're injured and you're bleeding, stopping that bleeding is called hemostasis. Where, again, we're not going to go through all the details of that process, but there are 3 steps. We'll just summarize. Hemostasis involves a vascular phase, a platelet phase, and a coagulation phase. So we're going to skip the notes, but I'm just going to show you here. The vascular phase begins when you have damage to a blood vessel. Possibly you were stabbed, or you cut yourself with a knife when you were doing food prep, in your kitchen. But it triggers a contraction of the smooth muscle fibers in the blood vessel wall, and those damaged endothelial cells, which are endothelium is the lining of the blood vessel, they become sticky. So you have this vascular spasm that occurs. And the platelet phase, you have platelets attaching to that sticky endothelium of the blood vessels. And then the coagulation phase involves the formation of fibrin and the formation of the actual clot, the actual blood clot. So that's just a very, very quick summary. I do want you to know that what's important to the clotting process are clotting factors. And they include calcium, vitamin K, and 11 different plasma proteins. So all of those are necessary for the proper blood clotting. So question 20, what are the effects of a vitamin K deficiency on blood clotting? Well, your blood's not going to clot as well. It's going to decrease the blood clotting process, and so you may have more bleeding than normal, or an area that's bleeding may not stop bleeding as quickly, that kind of thing.